ServiceFoundry. OBI enables instant observability for any containerized application using OpenTelemetry's eBPF-based auto-instrumentation. No need to touch your application code to capture traces or metrics. However, to correlate logs with traces, your application's logging configuration must be updated to include traceId and spanId in each log message. This minor change allows observability platforms like Grafana to connect the dots between traces and logs, providing full-stack visibility. With OBI, even legacy or third-party apps become traceable, and by adding a few lines of logging configuration, you gain powerful end-to-end correlation. Once the observability stack is installed, the Enable OBI button becomes active. This enables OpenTelemetry eBPF-instrumentation with just a click. Just like enabling observability, clicking Enable OBI triggers the ServiceFoundry builder as a Kubernetes job. This job automatically generates all the necessary Helm and customized manifest files for deploying OBI and fluent-bit and pushes them to your Git repository. From there, ArgoCD automatically picks up the manifests and deploys the required applications onto your Kubernetes cluster. This includes OpenTelemetry eBPF instrumentation and fluent-bit for collecting traces and logs. This seamless integration allows you to activate kernel-level instrumentation and log enrichment, fully GitOps-enabled without manually crafting YAML files or touching your workloads. On the left side of the screen is the ServiceFoundry Console dashboard, where users can trigger observability features like Enable OBI, which stands for OpenTelemetry eBPF-instrumentation. When the Enable OBI button is clicked, it launches the ServiceFoundry builder as a Kubernetes job. This job specifically generates Helm and customized manifest files only for the otel-ebpf instrumentation and fluent-bit components. On the right side, you can see the Git repository where those generated files are automatically pushed. These manifests are then picked up by ArgoCD, which deploys the instrumentation and log forwarding components onto the Kubernetes cluster. This GitOps workflow ensures traceability and repeatability of all observability components, letting users enable advanced observability in just one click without writing any YAML by hand. This slide shows how you can configure the OBI service discovery component. By default, ServiceFoundry generates a config map named obi-config in the O11Y namespace. This config tells the OBI agent which Kubernetes pods to instrument. On the left, you can see the default configuration. It targets pods in the ServiceFoundry namespace that are labeled with instrument OBE. On the right, we show how you can expand the discovery scope. For example, you can add the O11Y namespace to also instrument pods there as long as they have the same label. This setup makes it easy to control which workloads get instrumented by simply adjusting namespace and label filters without needing to redeploy or reconfigure the agent logic. This screen shows the ServiceFoundry console interface, specifically the ArgoCD view of the obi-configmap.yaml file. This config map defines how OpenTelemetry eBPF-instrumentation, or OBI, discovers target pods to instrument. In this example, the discovery rule is configured to instrument pods in the ServiceFoundry namespace that are labeled with instrument OBE. Another discovery rule is also defined to cover the O11Y namespace using the same label. Once changes are made to this file directly within the ServiceFoundry console, those updates are automatically pushed to the Git repository. Shortly after, ArgoCD will detect the changes and apply the updated configuration to the Kubernetes cluster, ensuring the new instrumentation rules are in effect. This tight integration between the console, GitOps, and ArgoCD streamlines OBI configuration and deployment with minimal manual steps. That brings us to the end of this session on enabling OpenTelemetry eBPF instrumentation with ServiceFoundry. We explored how to activate OBI through the Service Foundry Console, how it generates necessary manifests for otel-ebpf instrumentation and fluent-bit, and how everything is managed through GitOps automation with ArgoCD. In the next video, we'll walk through deploying a sample Go application so we can observe how OBI works in action, collecting traces, enriching logs, and correlating them using traceId and spanId. Thanks for watching, and I'll see you in the next one.